For the following questions, a normal distribution with a mean of 43.6 and a standard deviation of 3.6. We're going to use that for all 6 questions here. Which values are 2 standard deviations from the mean? To be 2 standard deviations from the mean, that means you are going to add 3.6 to 4.6 twice, and you're going to subtract 3.6 twice from 43.6. So when you add, if you take 43.6 and you add 2 sets of 3.6, that will be above, 2 standard deviations above, you get 50.8. So that's your one above. And then if you want the one below, you take 43.6 and you subtract 2 sets of 3.6 because you're going down 2 steps in standard deviations, which is 36.4. Those would be your 2 values that are 2 standard deviations from the mean. Next, how many standard deviations from the mean is 50? Well, you have to know your z-score formula. So z is equal to, and what you do is you take the value, which in this situation is 50, you subtract it from the mean, which is 43.6, and then you divide it by the standard deviation. It's a formula, you just got to plug them in. Or you can think logically. If you think about it logically, isn't this the distance from the mean? And aren't you dividing by standard deviations? And that will give you how many standard deviations you are from the mean. The formula actually does have makes logical sense. When you do that, you stick it in your calculator, and you end up with 1.78, or about 1.8. And that should make sense to you. If you think how many times, if I add 3.6 to this, if I do it twice, I'm above 50, and so it would make a little bit of sense that 1.78 makes sense. You want 1.78 standard deviations above the mean, not quite 2, and that should make some sense. Next, what percent of the data is above 40? So let's first think about where is 40. So, and we're going to graph it and look at it that way. So what I'm going to do first is I'm going to put the mean right here, 43.6. And then I'm going to subtract 3.6 until I get close to 40. So if I subtract 3.6, isn't that 40? Oh. Okay, so if that's 40, are we looking above? Aren't we just basically looking for all that? All the way to there. So that is everything above 40. And 40 is exactly 1 standard deviation below the mean. Oh, so that's actually pretty nice. You can actually use empirical rule here. The empirical rule is you can use it, just boom. That line, that is 1 standard deviation below the mean. This right here is 34%. Everything else on this side is 50%. Isn't everything half is 50? So 50 plus 34%, you have 84%. Now you could also use table A to do this one. If you use table A, what you would get is what's below this number, or 1 standard deviation, is about 16. I know they give you more decimals there, but what below would be 16, and you have to subtract that from 100. But I think it's easier to use empirical rule when they hit a nice breakpoint. But if they don't hit a nice breakpoint, you have to use table A. So for this one, we have to use table A. All right, for this one, you have to use table A. So to do this one, first let's draw it. So we have 43.6 here again. And then we're going to be adding 1 by 1 as we go left and right. Actually, we don't go left. Everything's above that. So we take 1 step to the right, and you have 47.2. Take another step, you have 50.8. And if we look at that, well, if we're doing 45, which would be somewhere around here, I don't know, in the middle, to 50, which is really close to here, aren't we looking at the space in between that, which would be all that? Okay, they're looking for what percent is that? Well, you can kind of maybe make sense of it if you know your empirical rule, but you need exact. So this is table A. So the first step is you need to do your z for the 45. So you do 45 minus 43.6 divided by 3.6. And when you do that, you get 0.39. Then we're going to find the z-score for 50, which we did already. Didn't we do that right here? Wasn't the z-score for 50 right here? So I could steal it from that problem, z-score of 50. So I'm just going to steal it. I'm a thief there, mathematical thief. All right, now from that you want to know between. So you have to look at the table A, and when you find on table A what is the amount below 50, well, actually you can't find 50 on table A. You have to do 1.78 z-score. So if you look at table A for 1.78, and the number below that, when you do that, is going to be 0.9625. And then you look at, not 45, but you look at 0.39 on table A. And the percent below that will end up being 0.6517. So those are the two values, the two areas below those two z-scores, and then you subtract the two. So you take 0.9625 minus 0.6517, and your answer is 0.3108. But how do you write that as a percent? You should know that's 31.08%. So 31.08% would be in this little green region. So next, what values are in the bottom 84% of the data? Shade the graph. So the bottom 84%. So if we think about that, well, isn't this right here, the bottom 84, wouldn't this right here be 34? Isn't the rest of this 50? So wouldn't below that green line be 84%, the lower 84% of the data? Oh, okay. We can use empirical rule. We don't actually have to look at table A, which would be kind of complicated. So what number is right here? Well, if we look right here, we did it. Isn't that 47.2? So if we look back at that, this is 47.2. So aren't we looking for values? I'll call them x, below or equal to 47.2. Is it anything below that or equal to that be in the 84%, bottom 84% of the data? All right, last one. Assume the sample size is 230. So, or assuming for this one. For a 90% level of confidence, what is the margin of error? This is your margin of error formula. So first thing we do is we look at this and we go 90%, so we want this number. So E, which is margin of error, is equal to 1.645. Now, we're going to multiply that by the S, which is your standard deviation. And we're going to divide that by the square root of N. N is your sample size, so that'd be 230. And then you just use your calculator. When you stick that in your calculator, you'll get E equals 0.39. That is your margin of error. Now you could apply that margin of error to your mean, but we're not going to, it doesn't ask for that. That would give your confidence interval. But we're just going to do the margin of error.